In this video, we are demonstrating the distribution trainer, the PSL40, from the Power Systems Laboratory range of teaching equipment from TecQuipment. This allows students on electrical engineering or power systems courses to investigate the final section of the electrical supply chain, how electricity is distributed to end users. This is done using real currents through real inducers and real system parts. By examining different aspects of electrical power distribution, from basic single-phase circuits through to balanced and unbalanced three-phase systems, students can learn about distributor volt drop, voltage regulation and line losses, as well as the effect of cable sizes and transformer tap changes. You can also learn about methods of volt drop compensation, system efficiency and protection, and much, much more. Let's take a look around it as I explain more about the functionality. The console area at the front has two main working sections, the upper for basic single-phase distribution and the lower for more complex three-phase distribution. Focusing now on the upper level, the upper left-hand section offers a basic distribution model in which the consumers are represented by the lamps and the distributor by variable resistors. These together provide a very visual method of teaching the fundamentals of distribution. These elements can be wired together using the supplied standard laboratory 4mm cables to represent the separate feeder, radial and ring configurations commonly found in a distribution system. Using this simple model, students get to grips with the fundamentals of a distribution system, allowing them to begin to understand what factors influence the volt at the consumer and how this voltage can be controlled. 9 analog meters are provided to allow quantitative analysis of the effects observed. 2 simple transformers are provided, one step up and one step down, linked by another section of feeder whose resistance can be changed to represent different length of cable between the substation and the first consumer. Power to this section is from a variable source that can be provided either low voltage AC or DC. Moving on to the lower panel now. This trains students on more advanced three-phase power distribution topics. It features 2 three-phase transformers, lines and load banks to simulate a medium to low voltage distribution system. One transformer, the line power here, reduces the voltage from the incoming laboratory main supply to the correct value for the experiments. And the other transformer acts as the distribution transformer to reduce the voltage down to consumer levels. This transformer also has adjustable primary taps used for voltage regulation experiments, and its secondary star point can be connected to earth. Between the 2 transformers are circuit breakers, meters and feeder models. The feeders are represented using the per unit system, a way of building a simulator so that it behaves the same as real-world systems. The three-phase line has multifunction measurement centers that measure up to 32 electrical quantities, including voltage, current, and the 3 powers are real, reactive and apparent, all on 3 phases. The 4 digital multifunction meters are identical in their measurement capabilities. All are connected to the line by current transformers. The front panel of each meter contains a liquid crystal display and push buttons for navigating the menu. The menus allow the meter to show either a small quantity of measurements with a large display or a large number with a small display. The meter for the low voltage section of the line after the distribution transformer has a floating bus bar that enables the meter to be inserted into the circuit wherever needed. A 10 amp ammeter is provided to measure neutral current. On the right side are the load banks. 3 kinds of loads are provided: resistive, inductive and capacitive. Each phase is adjustable independently and may be combined to produce loads with various power factors in order to see how this affects the system with line current, volt drop and efficiency. Let's talk about protection. When things go wrong in a power system, the results can be pretty spectacular. Equipment is in place throughout a power system to automatically cut off the power quickly when problems are detected. A common way to do this is by the use of protection relays. The PSL40 has 3 numerical protection relays from the Micom family, or up here. The P120 is the simplest of these and is intended to introduce the very basic of overcurrent protection. Whereas the most complex, the P127, using this, students can learn about directional overcurrent and explore the comprehensive fault and disturbance records that modern protection devices can provide. The protection relays are connected into the distribution system using current transformers, which are provided on the secondary side of both transformers. These protection relays are stimulated by applying various kinds of faults onto the system. The fault application switch provides an easy way to apply line to line to line, line to line to earth, and line to earth faults on the system. When the protection relay detects the fault, it opens the circuit breaker that feeds the line. Fault resistors are provided so that the magnitude of some types of fault can be controlled, allowing the distribution of the fault current to be observed and studied. You can study more advanced topics such as differential protection and distance protection with these other products available from TecQuipment. To summarize, the Power Distribution Trainer allows you to learn in depth about radial and ring systems with different load types, distribution losses and efficiency, voltage control through reactive power compensation, effect on line current and efficiency of improved power factor, use of tap distribution transformer for load voltage control, 3-phase distribution system with balanced and unbalanced loads, effect on an open circuited neutral conductor on a 3-phase distribution system under fault conditions, and protection relays and their setup and use. There's a whole lot going on with this trainer. I've just covered it in a very high level. It comes with a 198-page user guide that goes into great depth to explain all the elements with step-by-step guides through experiments for a detailed study of power distribution. The Power Distribution Trainer is one of 5 modules that form the Power Systems Laboratory from TecQuipment, which means it can be connected to other components such as a generator, transformers and transmission lines, as well as being used as a standalone trainer that we show set up here today. This is what the entire system might look like if you had all 5 modules in place with a hub connecting them together. For more information on the Power Distribution Trainer, the PSL40, or any other products within the range, click on the links below. If you like this video, please give it a like and feel free to post your questions in the comments box below. Thanks for watching.